Hi, good afternoon. So we had another question regarding question 43 in section 2.2. Write the linear function in the form f of t is equal to b plus mt. State the values of b and m. Now also, more directions also say that your answer could include constants such as k and c. Okay, before we do this problem, I need to throw this out here. A lot of students are getting confused by this notation right here. F of t is equal to b plus mt. Okay? Which is understandable. I can definitely understand the confusion. So, let's do a little playing around. F of t equals b plus mt. Well, in this section, we're starting to deal with equations in slope-intercept form. Well, I guarantee you probably have never seen that form before. You probably have seen other variations, such as y equals mx plus b. Okay, that's the traditional slope-intercept form that most students are familiar with. Now, since this course deals with functions more than anything, anytime you see a y, you always want to put f of your variable, f of something. Usually in our case, we deal with f of x. So, as a function, this standard notation of slope-intercept form can be rewritten as f of x equals mx plus b. Okay, that's function form of our slope-intercept form that we're familiar with. Okay? Now, how that correlates to f of t equals b plus mt, it's the same type of formula. The only difference, instead of having an x, we're dealing with t's. Now, you're probably wondering, why in the world do they do that? Why do they deal with t's and not x's? Well, the thing is, most functions in applied algebra, even in physics and engineering, a lot of things are a function of time, t. So a lot of the models, a lot of the problems that we deal with relate to how time progresses. So that's actually why they deal with b plus mt. Okay? So if you wanted to rewrite this as this, well, instead of having x, we would have a t, and this would be mt plus b, or, switch it around, b plus mt. Okay, it's the same formula, you're just using different letters. That's all it is. Okay? So I just want to make sure we get that out in the open, make sure that, you know, the confusion does happen, but it all stems back to this form that we're familiar with, at least back in high school or other institutions. Okay, it's still slope-intercept form. We're just seeing it in a function notation. We're seeing it as t is your variable instead of x. Okay. Now, going back to the original problem, write the linear function in the form f of t is b plus mt. Okay. Now, f of t is 6ct minus 3kt minus t plus kc plus 2k minus 3. Okay, a lot of stuff going on. So what we need to do, we need to combine or organize everything that has a t with it. Everything that does not have a t with it, we, in a sense, yank it out. So here, well, actually, the way the problem was written, it actually works itself out. The reason why I'm saying that is because all of your terms that have a t with it, they're already side by side. So that makes it easier to factor stuff. Everything that does not have a t with it, that's what we consider your constant values. That's our non-variable terms. So kc, k, and of course 2 and negative 3, those are considered our constants. So everything that has a t with it, that's what we have to play around with. So we've got 3 terms with a t with it. So if we factor out the greatest common factor, which is a t, Well, if I take out a t from each one of these, well, I have 6c minus 3k minus 1. Okay? Let's go through that. If we take out a t from each one of these guys, I'm just left with 6c minus 3k, and negative t divided by a positive t, that's where that negative 1 comes from. As always, if you want to double check, distribute your parentheses back in. Okay, so t times 6c will get you 6ct, t times negative 3k gets you a negative 3kt, and t times negative 1, that's where that negative t comes from. Okay, so when in doubt, always FOIL back in, double check yourself just to make sure. Okay, so now that we factor the greatest common factor from these guys, we can just bring everything else down. Let me get my marker color right. Minus kc plus 2k minus 3. Alright? So, in the form of b plus mt, and state your values of b and m. For me personally, as your instructor, it does not matter to me if you have it listed as mt plus b or b plus mt. It does not matter. The reason why I'm saying that is because the addition is commutative. Does not matter which order you have it as long as it's there. So here, we can actually say that the stuff being multiplied by the t, that would be considered our m value. So this stuff right here in the parentheses, that's our value for m. And this stuff right here, that would be our value for b. Okay? So, mt plus b. Okay? So, whenever you're doing this problem in Wiley Plus, your m value would be 6c minus 3k minus 1. Your b value would be minus kc plus 2k minus 3. Okay? So, a lot to type in. But, like I said, it doesn't have to be, like this stuff doesn't have to be first and this stuff has to be last. I don't think Wiley Plus even matters or even cares about that. Even for me as your instructor, I don't care. So as long as it's there, as long as the signs are correct, you're good. So really in this problem, it's just really a matter of factoring out your greatest common factor for your variable and and trying to get into the form that the problem recommends. So, as I always say, let me know if y'all have any questions. I'm starting to make more and more of these videos, so keep them coming, guys. That's what I'm here for, okay?